Hi, I'm Sally Gray. Welcome to the Key Stage 3 Bite-Size Revision Series and Maths. If you're sitting your Key Stage 3 test this summer, then it's probably a very good idea indeed to start planning your revision as soon as possible. And there are a number of maths programs in this series with units that cover the main elements that you need to revise for your up-and-coming tests. Now, the idea is that you can work your way through the whole menu or just concentrate on the areas where you feel you need the most practice. Whatever, the choice is yours. If you're needing help with your maths revision, then this is the place to be. And these are the topics we're looking at in this programme. There are several units on number, and there's a survival guide to the tests with advice from students who've already taken them. Before each unit, you'll see the menu, so you'll know what's coming up and where we've got to. The great thing is you can use this programme in bite-sized chunks. There's a timer to help you find your way through, so you can always fast-forward to the units you need the most help with. The crucial facts, the most important things to remember, are the key points. And you may find it useful to take notes on these as you go along, especially on the maths that you find a little bit tricky. So don't forget a pen and paper. There are also lots of real test questions coming up that you can try out for yourself. And if you want, you can always stop the tape and have a go before playing on to find out the answer. And there's more information, exercises and questions for you to practice in the Key Stage 3 Bite-Size Revision book and on the website that go with these programmes. And whether are linked with the book or with the website, you'll see these icons on the screen. Basically, it's important to remember that revising maths is all about practice and working through the questions yourself so that you're well prepared for the test. The Key Stage 3 tests are designed to see how well you manage with your mental maths and your calculations on paper. Now, sometimes you will be allowed to use a calculator and other times you'll have to work without it. So watch out for instructions on the test papers. In the mental maths test, you'll answer questions played on an audio tape and you have to do all the calculations in your head. If you can't answer a question, don't spend too long on it. Just move on. Otherwise, you won't hear the next question and you'll end up losing marks. And there's a mental maths test to try on our website. In any written papers, it's essential to show how you worked out the answer. Even if you make a mistake and your answer is wrong, you may still get some marks if the examiners can see that you knew what you were doing. But examiners aren't mind readers. If you don't show your workings and your answer is wrong, they can't give you any marks at all. For the written papers, you'll need to take in equipment like a pen, pencil, pair of compasses, angle measurer, tracing paper, mirror, and of course a calculator for the calculator paper. Check with your teacher what will be provided and what you'll need to bring yourself. Preparation is really important, so well before the test, it's a good idea to put together a revision plan for the 3 subjects you'll be tested on at Key Stage 3. That's Maths, English and Science. Try to start your revision early, at least 2 months before the test if you can. But hey, any preparation before the test is better than none. Space out your revision. Don't try to revise everything in one go. Revising in bite-sized chunks is usually more effective than trying to cram it all in at once. So decide how much material from the maths programmes you'll revise each week in order to cover everything in time for the test. Oh, and don't forget to take regular breaks when revising.
I revise about 6 o'clock at night for about an hour, 2 hours in silence. So because if I've got music on or other background stuff, I can't really hear and take it in properly.
When you're revising, don't try to do as much as you can. I mean, do 45 minutes or so, then go and watch a bit of telly and have something to eat and stuff before you start again, because otherwise it'll just be a bit clogged up in your head. You should like write your revision on cards so you can like look over them again.
To remember things, I stick a piece of paper on the door with the information that I have to revise, and then I'll close my eyes and say the information that I have to remember, and then go in and through the door, and the same when I come out.
I'll keep my music on because I like to revise with noise around me. Then I'd like have little breaks in between to get chocolate.
You should always feel confident and ask your family and friends to help you out.
Okay, let's recap on the main points to remember, and you might like to jot some of these down. Make a revision plan for all 3 subjects, maths, English and science, and give yourself as much time as you can. Revise in bite-sized chunks. Don't stay up revising the night before because last-minute revision often doesn't sink in. The night before the test, try to get a good night's sleep. Rest is best for a test. And make sure you have all the right equipment for each test. Now, here's another good tip for you. Collect together all the equipment you'll need for each test now. This will give you plenty of time to buy or borrow anything that may be missing from your pencil case. And check that you still have all the right equipment the weekend before the test, so you don't have a mad panic on the day itself. This unit on whole numbers and decimals is divided into 3 sections. First, let's revise place value and check through a few basics. Place value is about what each digit represents within a number. For example, the digit 2 can represent 2 units, 2 tens or 20, or 2 hundreds or 2 thousands. The digit remains the same, but when its position in the number changes, so does its value. So if we take a 3-digit number, we can put it into columns, units, tens and hundreds. And if it extends to a 4-digit number, there will be a thousands column as well. Take the digits 1, 5 and 6. In this roll of cards, we've got 651, 561 and 615. In the text, the type of question you might be asked is numbers like these in order of size. Let's start by asking an expert, a teacher.
Okay, I've got the hundreds column, the tens column and the units column. Now let's look in the hundreds column to see which has got the most number of hundreds in it. 6, 5 or 6. Now we can see straight away which has got the least amount of hundreds in it, and that's 561. So let's write that. $561 is the smallest number. Now let's try and work out which number goes next. Let's go to the hundreds column again. 600s, 600s. That doesn't really help us, so let's go into the next column, which is the tens. We've got 5 tens in this number and 1 10 in this number. Which is the least amount of tens? 1. Okay, so which number goes next? 615. Now, which is the largest number? Well, we've only got one number left, which is 651. Let's just check that that is the largest number by looking in the tens column. It's got 5 tens, which is more than 1 10. So we can tell that that is our largest number, 651.
Okay, here's a typical test question for you, where you'll need to use the skills we've covered so far in this section on place value. There are 3 parts to this question, and you might like to jot some of the figures down. Here are some number cards. 1, 7, 3, 5. You can use each card once to make the number 1735, like this. 1, 7, 3, 5. Use the 4 number cards to make numbers that are as close as possible to the numbers written below. As part of this question, we're given an example 8,000 and told that 7,531 is the number closest to 8,000 using just those digits. The numbers you have to try and match as closely as possible are 4,000, 1,500 and 1,600. Make a note of them and also the digits you can use. That's 1, 7, 3 and 5, and work it out for yourself before playing on to the answer. Or you can tackle the same question on our website. Right, how did you get on there? Well, who better to go to for the best possible answer than the lead chief marker for Key Stage 3 Maths? And he's going to go through it part by part. First, part 1.
We're trying to make our number as near as possible to 4,000. So start by putting the digit nearest to 4 in the thousands column on the far left. This could either be 5 or 3. If we put the 3 there, we'd be below 4,000. And if we put the 5 there, we'd be above 4,000. So which do we choose? By putting the 3 there, with the other cards in any order, we'd always make 3,000 and something. So the difference between this number and the target number, 4,000, must be less than 1,000. If the 5 goes in the thousand column, we have 5,000 and something, whatever the order of the other 3 digits, making a difference of more than 1,000. So 3 in the thousand column. Then we need to get as close to 4,000 as we can by using the other 3 digits to make the number as high as possible. So the highest digit in the hundreds, that's 7, followed by 5 tens and just 1 unit. That makes the answer 3,751.
So, did you get it right? And if you're not sure about the answer or how to get it, don't worry, just replay and try it again. Writing it down will help too, otherwise move on to part 2. Which number is as close as possible to 1,500?
We can match the thousands and hundreds exactly by putting 1 and 5 in the first 2 columns. That gets it quite close to 1,500. Then with the other 2 digits, it could be 7 followed by 3. That would be 73 above 1,500. But in fact, the 3 followed by the 7 would be a closer fit because it's only 37 above 1,500. So let's go for 1,537.
And now, the final part. Make up the number closest to 1,600.
To make it closer to 1,600 than to 1,500, we need to make the tens as high as possible. So it must be 7 followed by 3. 1,573. That's 27 below the target number. Now we will check by going above 1,600 and look at 1,700 and something. That would be more than 100 above the target number. So we were right. 1,573 is the closest we can get to 1,600.
Okay, we're nearly at the end of this section on place value. Let's now have a look at the key points you need to remember. Place value tells you what each digit represents within a number. So in the number 8367, the 8 means 8,000s, the 3 means 300s, the 6 means 6 tens, and the 7 means 7 units. It's really worth reminding yourself about place value because it's vital for calculations and it's important to get to grips with these basics before moving on. If you want to go through any of this section again, then this is the time to stop the tape and rewind. And remember, there are always more questions to practice in the Key Stage 3 Bitesize Maths book and on our website. Now that we've looked at place value for whole numbers, let's move on to decimals. In this long jump, the distances being jumped by the athletes are expressed as decimals. So this athlete has jumped 8.22 meters. Whenever we're working with decimals, we do our calculations just like we would with whole numbers. That goes for adding, subtracting, multiplying and dividing. But keeping the columns in line and the decimal point in the right place is crucial. And remember, one decimal place means one digit to the right of or behind the decimal point. 2 decimal places means 2 digits behind, and so on. Right, let's go back to our long jump example. 3 athletes jumped 8.22 metres, 7.66 metres and 8.05 metres. So who jumped the furthest?
We need to find the largest, so let's look in the first column. We still have our units column here, and then we've got our decimal point, and then we've got the tenths column and the hundredths column. Go back to the units column, our first column. Which is the largest number here? We've got 2 8s and a 7. So straight away we can tell which is the smallest number because we've got a 7 in the unit. So that we can write down as our smallest number to get it out of the way. So let's write that here. So 7.66 is the smallest number. Now let's look for the largest number. 8 units, 8 units. It doesn't help us. Let's move on to the tenths column. 2 tenths, no tenths. So which has got the largest amount of tenths? 2. Okay, so that one, 8.22, is the largest number. So let's write that down. 8.22 is our largest number. What's left? 8.05. So that must be the number that goes in between. Okay, so we've ordered the numbers by using our columns to help us. One thing you must remember also is to keep your decimal point in exactly the same place all the time.
Now watch out for a really common mistake. 8.9 can also be written as 8.9 naught. The naught in the hundredths column can be written in or left out. When you compare decimals, work from the left to the right. Compare the units before the tenths and the tenths before the hundredths. Another way of looking at this would be to make the same comparison with money. 8.9 in pounds would be £8.90. 8.45 would be £8.45. And which would you rather have? I'd go for £8.90. And finally, let's look at numbers to 3 decimal places.
Okay, let's look at our grid. We've got an extra column here. We've got the thousandths column now. Still got the units, decimal point, tenths, hundredths and thousandths. Now when we're ordering our numbers, even though they're to 3 decimal places, the method is still the same. So let's take our numbers first. We've got 8.654. We've got 8.656. And we've got 8.907. Okay, let's look at our first column, units. They've all got 8 units in them, so that doesn't help us. Let's move into the next column, tenths column. 6 tenths, 6 tenths, 9 tenths. So which is the largest number? 8.907. Okay, let's write that down as our largest number. 8.907. Okay, so we've got that one out of the way. Let's go on to find the next largest number. Units are the same. Let's move on to the next column. Tenths are the same. Let's move on to the next column, the hundredths column. 5 hundredths, 5 hundredths. Still doesn't help us. Let's go on into the thousandths column. 4 thousandths, 6 thousandths. Which is more, 6 or 4? 6. So that's our next largest number. Let's write that down. 8.656. We're left with one number, 8.654, which must be the smallest number. So let's write that down.
Always look where the decimal point is. Keep all of the corresponding columns, the units, tenths, hundredths and thousandths, lined up. Now, what about rounding up and rounding down? We round up and down when we want to approximate. This makes numbers easier to work with and can also be used in estimating complicated calculations.
When we're rounding numbers up or down, we can use a number line to help us. I've got a number line here with the numbers 7.9, 8.0, and 8.1 on them. Now this is the number 7.94 that I want to round up or down to 1 decimal place. Okay, let's see where it might fit on our number line here. We know for a start that 7.94 is more than 7.9 because it's got 4 hundredths as well. But we also know it's smaller than 8.0, okay, because it's only got 7 units. So we know it's got to be somewhere here. Let's divide this number line up even more. Let's take the midpoint here and say that this is 7.95. Where do you think 7.94 is closest to? Is it on this side of 7.95 or this side of 7.95? Well, you know that it would fit here. So if we want to round 7.94 to 1 decimal place, we would round it down to 7.9.
So remember, if the digit to the right of the one we want to round to is 5 or more, then round up. If it's less than 5, round down. Right, while we're using number lines, think about this one. 7.9 plus 0.1. Now a mistake that's made quite often here is to think that because 9 plus 1 is 10, 0.9 plus 0.1 is 0.10, and that's wrong. And just to make sure you never make that mistake, look at it on the number line. Adding 0.1 to 7.9 would move it along the number line to the right, giving us 8.0. 7.10 on the other hand, or 7.10 as I should say, is actually just the same as 7.1. Okay, now on to addition and subtraction of numbers to 2 decimal places.
It's just the same as any other addition sum, but the one thing you must remember is that you keep the decimal points in exactly the same place. They must not move. So let's start with this column, the hundredths column first. 0 add 5 is 5. 3 add 2 is 5. The decimal point in exactly the same place. And 5 plus 6 is 11. Now let's move on to subtraction. The first thing to remember is that all our decimal points are in exactly the same place. So we'll do this just like any other subtraction sum. Let's start with this column first. 5 minus 0 gives you 5. Now you can't do this, 2 minus 3. So what do? We borrow a unit from this side, okay? So we take one from the 6 over to here. Because we've taken one away, we need to remember that and write a 5 up there, okay? Now let's try and do the rest of the sum. 12 minus 3 is 9. Decimal point in the right place. 5 minus 5, 0. So the answer is 0.95.
And finally, let's check through multiplying and dividing decimals by whole numbers.
We've got 4.13 multiplied by 7. We do that just like any other multiplication sum, but we must remember to keep the decimal point in the same place. That would follow to here. Now I'm going to do it just like any other multiplication sum, starting from this end. So 3 multiplied by 7 is 21. Carry the 2. 1 times 7, 7. Add the 2 is 9. Decimal point in the right place. And then 4 times 7 is 28. So 4.13 multiplied by 7 gives you an answer of 28.91. Now let's move on to division. But first we put the decimal point in. Then 7 into 2 doesn't go, so we carry it. 7 into 24 goes 3 times, with a remainder of 3, which we carry over again. Now we do 7 into 35. That goes neatly 5 times. Finally, 7 into 7 goes once. So that's 1. So 24.57 divided by 7 is 3.51.
Because the number in the question, 24.57, was written to 2 decimal places, then your answer should also be to 2 decimal places. In fact, in any decimal calculation, match the number of decimal places in the answer to the highest number of decimal places in the question. Right, now time for a test question, and this one's in 4 parts, so you'll need to jot the figures down if you want to try it for yourself. Oh, and don't forget to show how you worked out your answer. Part A says, a shop sells videotapes for £2.50 each. What is the cost of 16 videotapes? Part B says, the shop sells audio cassettes. Each cassette costs £1.49. What is the cost of 4 cassettes? And C, how many audio cassettes can you buy with £12? And Part D, the shop sells audio cassettes in packs of 3. A pack costs £3.99. How many packs can you buy with £12? It's a good idea to stop the tape and try to answer the question yourself. This one has to be done without a calculator, and don't forget to show how you worked out your answer. Right, how did you get on there? If you want to hear from the lead chief marker, play on, and he'll work through the question 1 part at a time. First, Part A. 1 tape costs £2.50. How much would 16 tapes cost?
The answer must be £2.50 multiplied by 16. There are lots of ways to multiply by 16. Here's one. £2.50 multiplied by 10 equals £25. If you halve this, you get £2.50 multiplied by 5, which is £12.50. Add those together, and that gives £2.50 multiplied by 15. So now we just need to add one more £2.50 to get £2.50 multiplied by 16. If you add them all up, you get £40. Another way to multiply by 16 is to multiply by 2 and then by 8. 2 times £2.50 is £5, and 5 times 8 equals 40. That's a nice quick way to get to the answer. You may have a different method of doing this calculation. If it's a method you're happy with, and you can show you're working, and get the right answer of £40 at the end, then that's fine.
Okay, so far so good. What about Part B? That gives you the price of cassettes, £1.49 each, and asks you to calculate the cost of 4.
Well, you need to multiply £1.49 by 4. One way of doing this is to think of £1.49 as nearly £1.50. £1.50 multiplied by 4 is £6. Because £1.49 is 1 penny less than £1.50, you have to take away 4 times 1 penny, giving an answer of £5.96.
Now remember, when multiplying a whole number by a decimal, make sure that the number of digits behind the decimal point in the answer is the same as it was in the question. Now, what about Part C? How many cassettes can you buy with £12?
One cassette costs £1.49, so you need to divide £12 by £1.49. But £1.49 is nearly £1.50. So you work out the number of £1.50s there are in £12. There are 2 £1.50 in £3 and 4 lots of £3 in £12. So there are 4 lots of 2, making 8 £1.50s in £12. As £1.49 is 1 penny less than £1.50, there would be a remainder. But the question is asking how many cassettes can be bought with £12, so the answer is 8.
And finally, Part D. The shop also sells cassettes in packs of 3, and a pack costs £3.99. How many packs can be bought with £12?
£3.99 is nearly £4, so it's a matter of dividing £12 by £4, which gives an answer of 3 packs.
And that would be a pretty good buy, because for the same money you get 3 times 3 makes 9 cassettes by buying them in packs, and only 8 by buying them individually. Bargain or what? Right, We've looked at adding and subtracting decimals, as well as multiplying and dividing decimals by whole numbers. And you've tried an actual test question. So let's recap what we've done so far. When adding and subtracting decimals, keep the decimal point in line. Keep the numbers in the right columns, example units under units, tenths under tenths, and so on. Add and subtract as you would for whole numbers. And when multiplying and dividing a decimal by a whole number, keep the decimal point in the same place in the answer as the decimal number you are multiplying or dividing by. Multiply or divide as you would for whole numbers. That's the end of this section on decimals. Remember, if there's anything you want to double check, stop the tape and rewind. And don't forget, there's our website and the Key Stage 3 bite-sized book, where you can find more examples and test questions to work through. In this section, we're going to remind ourselves about multiplying and dividing both decimals and whole numbers by multiples of 10. A multiple of 10 is a number that 10 divides into. For example, all the numbers in the 10 times table. First, a quick reminder of multiplying by 10, and then by 10 times 10, 100, and then by 100 times 10, 1,000. And the rule to remember here is, to multiply or divide by a multiple of 10, like 30, 300 or 3,000, you need to multiply or divide by the 10, 100 or 1,000, and then by the 3. Let's now look at a few examples.
Let's start with something really easy first. We've got 4 multiplied by 10, which gives you an answer of 40. If you look, we've moved the digits one place to the left. Okay, now let's do another one. Let's do 4 multiplied by 100. The answer is 400. Again, we've moved the digits this time 2 places to the left. Let's do this one now. 4 multiplied by 1,000, which gives you 4,000. This time the digits have moved 3 places to the left. Now let's move on to slightly larger numbers. If we wanted to multiply 4 by 30, for example, first thing you'd have to do is look at what the 30 is made up of. That's actually 3 lots of 10. So let's break it up. We've got the 4 multiplied by 10 multiplied by 3, because we've got 3 lots of 10. Okay, let's do this sum. 4 times 10 is 40, multiplied by 3 gives you an answer of 120. So 4 times 30 is 120. Now let's move on to a slightly larger number. 4 multiplied by 300. 300 is 3 lots of 100. So it's 4 multiplied by 100 multiplied by 3. So that's 400 multiplied by 3 gives you an answer of 1,200. Okay, let's take one last example with a slightly larger number. Okay, this time we'll have 4 times 3,000. And again, let's look at what the 3,000 is made up of. 3,000 is actually 3 lots of 1,000. Okay, so let's do 4 multiplied by 1,000 multiplied by 3. So 4 times 1,000 is 4,000 multiplied by 3 gives you an answer of 12,000. Okay, so 4 times 3,000 is 12,000. Okay, moving on to decimals now. We've got 5.6 multiplied by 10. Let's write that decimal in. 5.6. Now this time, the digits will move one place to the left. So the 5 will end up in the tens column here. The 6 will end up in the units column here. So 5.6 multiplied by 10 is 56. Now let's move on to a larger number. Now we've got 5.6 multiplied by 100. This time again, let's write the decimal in, 5.6. Now this time the digits are going to move 2 places to the left. So the 5 is going to go 2 places into the hundreds column. The 6 is going to go 2 places into the tens column, and we don't have any units, so we keep a 0 there as a placeholder. So 5.6 multiplied by 100 is 560.
So when multiplying by 10, 100 or 1,000, move the digits to the left so that the number gets bigger. And when dividing by 10, 100 or 1,000, move the digits to the right so that the number gets smaller. Okay, let's look at some more examples.
Let's take 4,000 divided by 20. We've got 4,000. Let's divide it by 10 first to make it easier. That gives us an answer of 400. We want to divide it again. So do we divide that again by 2? And that gives us an answer of 200. So 4,000 divided by 20 gives you an answer of 200. Now let's take a larger number. This time we've got 4,000 divided by 200. Again, let's write the 4,000. Divide that by 100. And that gives us an answer of 40. But we need to divide it by 200. So let's divide it in half. And that gives us an answer of 20. So 4,000 divided by 200 equals 20. Now let's do one more with an even larger number. And this time we've got 4,000 divided by 2,000. Again, 4,000 divided by 1,000 first to make it a little bit easier. That gives us an answer of 4. And then we can divide that by 2, which gives us an answer of 2. So 4,000 divided by 2,000 equals 2.
Right, what about decimals?
Right, let's do this sum now. 5.6 divided by 100. Now let's write the decimal number in here, 5.6. Because we're dividing, the digits move to the right. Because we're dividing by 100, and 100 has got 2 noughts in it, we're going to move our digit 2 places to the right. So 5.6 will become 1, 2. Let's put the 5 there, and the 6 here, a 0 as a placeholder, decimal point, and a 0 here. So 5.6 divided by 100 is 0.056. Now let's move on to a slightly harder sum here. This time we've got 5.6 divided by 1,000. Again, let's write our decimal in first. Because we're dividing, the digits move one place or they move to the right. In this case, we're dividing by 1,000. Look how many noughts are in 1,000. 1, 2, 3. That tells us that our digits must move 3 places to the right. So let's take the 5, and that will go 1, 2, 3 places to the right, followed by the 6, and put our noughts in as placeholders. So 5.6 divided by 1,000 is 0.0056.
If you do happen to come across a test question like this, and in the heat of the moment you can't remember which way to move the digits, whether it's left or right, then here's a good tip. When you multiply any two numbers greater than 1, the answer will be bigger than either of the numbers in the question. When you divide any two numbers greater than 1, your answer should be smaller than the number being divided. And remember, to multiply or divide by a multiple of 10, like 50 or 500, you need to multiply or divide by the 10 or the 100 and then by the 5. You do get questions about this quite a lot, and it's a useful method to bear in mind when you're solving practical problems. Each of these calculations is missing either 10, 50, 100, 500 or 1000. Fill in the gap with the correct missing number. Jot down the numbers and have a go yourself. 1.20 multiplied by one of these numbers gives 120. then 12 divided by another gives 1.2. 12 multiplied by another gives 6,000. 0.6 multiplied by another gives 600. And finally, 600 divided by one of the numbers gives 12. Before we work it out together, it may be a good idea for you to stop the tape and have a go at the question yourself. Okay, now for the answers. And once again, we're going to hear them from a senior maths examiner. First of all, 1.20 multiplied by one of these numbers gives 120.
1.20 has been multiplied by a number that has simply moved the figures to the left without changing them. This means that the missing number must be 10, 100 or 1,000. The figures have moved to the left because we're multiplying, and they have moved 2 places, which means that the missing number must have 2 zeros. So the answer you want is 100.
Great, let's move on to part B. 12 divided by what equals 1.2? And the question doesn't say that the missing numbers only appear in one calculation, so keep looking at all of them.
Again, 12 has been divided by a number that has simply moved the figures to the right without changing them. This means that once again the missing number must be 10, 100 or 1,000. This time the figures have moved to the right because we are dividing, but they have moved only one place, so the missing number must be 10.
And now the next one, part C. 12 multiplied by a missing number, 10, 50, 100, 500 or 1,000, gives the answer 6,000.
Here 12 must be multiplied by something other than 10, 100 or 1,000, because the digits 1 and 2 do not appear in the answer. So 12 must be multiplied by 50 or 500. Now 12 multiplied by 5 is 60, but we want the answer 6,000. This is 100 times bigger than 60. So if we multiply 12 not by 5, but by a number 100 times larger, that's 500, this gives the answer 6,000.
Okay, next, part D. Now 0.6 multiplied by what equals 600?
We can see that 0.6 has been multiplied by a number that has simply moved the figure to the left without changing it. So this means that the missing number must be 10, 100 or 1,000. The figure has moved to the left because we are multiplying, and it has moved 3 places, which means that the missing number must have 3 zeros. So the missing number must be 1,000.
Right, it's now time for the final part. 600 divided by which of the missing numbers gives the answer 12?
So 600 must be divided by 50 or 500. 60 divided by 5 is 12, so 600 divided by 50 will also be 12. That means the missing number must be 50.
Okay, let's now check through the key points we need to remember. When multiplying by 10, 100 or 1,000, move the digits 1, 2 or 3 places to the left. The number gets bigger. And when dividing by 10, 100 or 1,000, move the digits 1, 2 or 3 places to the right. The number gets smaller. You can find more questions that ask you to multiply and divide by 10, 100 and 1,000 in the Key Stage 3 book and on our website. But for a real-life example to see just how important multiples are, take a look at this clip.
Why do people always get it wrong? Genesis chapter 1 verse 20. And the Lord said, "Be fruitful and multiply." Nobody knows quite when we started, but 3 million years ago there were probably only a few 100,000 people on Earth, roughly the population of Derby. By the end of the Ice Age, there were about 4 million human beings. These days, there's really rather a lot of fruitful multiplying going on, rather too much, in fact. You see, the bigger the number of people, the more of them can be fruitful and multiply at any one time. So the bigger the population, the faster it grows. The number of people who watched the last World Cup final was more than the entire human race just 500 years ago. 5,000 million people now live on our little Earth, and the population is now multiplying by 2 every 37 years. Perhaps we need to find a new way to divide our time.
Right, this is the end of the unit on whole numbers and decimals. If you want, you can rewind the tape and replay it as many times as you like until you feel confident enough to move on. In this unit, we're going to look at basic fractions, converting between fractions and decimals, and adding and subtracting fractions. First, let's check through a few basics. Okay, a fraction is a part of a whole. The bottom number is called the denominator and tells us how many equal parts the whole is divided into. The top number is called the numerator and tells us how many of those parts make up the fraction. In simple terms, you can think of fractions as slices of pie or bits of pizza, but it's probably more helpful to look at fractions of a number or set of items. For an example of fractions in real life, let's go to an expert pool player. In pool, the balls are arranged so that there are 7 red, 7 yellow and 1 black. The different coloured balls in the triangle can be thought of as a fraction of the set of 15 balls. Let's look at the red first. There are 7 red balls out of a total of 15 in a triangle. They represent 7 out of 15, or 7/15ths of the whole set of 15 balls. Same for the yellow. 7 balls out of 15, 7/15ths of the set. The 1 black ball is 1 out of 15, or 1/15th as a fraction of the whole set of 15 balls. Adding all of these up, we have 7/15ths and 7/15ths and 1/15th, giving us an answer of 15/15ths altogether, and that, of course, equals 1 whole. Okay, let's recap before moving on. A fraction is a part of a whole. The top number of a fraction is called the numerator and the bottom number is called the denominator. The denominator tells us how many equal parts the whole is divided into, and the numerator tells us how many of those parts make up the fraction. So we've looked at some examples of basic fractions. Well, now our pool player is going to break the rules of the game just for us and arrange the different coloured balls in a new way, in a rectangle. This time he's arranging it with 5 red, 5 black and 5 yellow balls. So there are 5 out of 15 of each colour. As a fraction, that would be 5/15ths. But we could simplify the fraction by cancelling down. We use cancelling down when we divide the numerator and denominator of a fraction by the same number. For example, 5/15ths. The numerator and denominator are both divisible by 5. 5 divided by 5 comes to 1, and 15 divided by 5 comes to 3. This makes the fraction 1/3, and you can see that each colour makes up 1/3 of the rectangle of balls. So that's the basis of cancelling down. But what if we want to work out a fraction of a different number, like 3/5 of a £20 note? What is 3/5 of 20?
If we want to find 3/5 of 20, the easier way of doing it would be to find 1/5 of 20 first. So if we want to find 1/5 of 20, we have to divide 20 by 5. So let's do that. 20 divided by 5 is 4. So 1/5 of 20 equals 4. We want to find 3/5 of 20. So we can take the 1/5, which is 4, and multiply it 3 times. And that gives us an answer of 12. So 3/5 of 20 is 12.
Okay, let's summarise. We simplify a fraction by cancelling down or dividing both the numerator and denominator by the largest number that will divide into both. To find a fraction of a quantity, first of all divide by the denominator and then multiply by the numerator. Now let's move on to converting between fractions and decimals. Let's go back to the pool table where our pool player is about to break. This time there are 10 balls. He pots one ball, taking away 1 out of 10, or 1/10 of the set. Okay, basics first. Remember what 1/10 means in decimals?
Let's look at 0.1 now. We have no units and we have 1/10 after the decimal point. Let's put that number onto a number line, okay? It will go somewhere between 0 and 1. 0.1 goes here, followed by 0.2, and you carry on until you get to 0.9, and then you have 1 whole 1. Or you can put it on a fraction number line between 0 and 1 again. Here you'd write it as 1/10, followed by 2/10, and you'd carry on till you get to 9/10, and then it'd be followed by 1 whole 1.
Now our player is going to pot 2 balls, or 2/10.
Now let's take 0.2. We have no units and we have 2/10, so we can write it like this. Now we can cancel this fraction down by dividing both the denominator and the numerator by 2. So 2 into 2, 1 and 5. So 0.2, the decimal, can be written as 1/5 as a fraction.
Let's take a number to 2 decimal places. What about 0.25?
Here we have no units, 2/10 and 5/100. So that can be written as 25 over 100. Okay, let's find a common factor so we can cancel that down. And that would be 25. So that's 1/4. So 0.25 can be written as 1/4.
Okay, how about a number to 3 decimal places, like 0.255?
Here we've got no units, 2/10, 5/100 and 5,000. So you'd write that as 255 over 1,000. So we find a common factor. Let's divide it by 5, which gives you 51 over 200. So 0.255 converted into a fraction is 51 over 200. Now it's worth remembering, when you're converting decimals to fractions, however many numbers or digits you have after the decimal point, that will be exactly the same as a number of zeros in your denominator. Let's take some examples here. 0.2. That's 1 digit after the decimal point, 1 0 in the denominator. Let's take another example, 0.22. You've got 2 digits after the decimal point. How many noughts have you got in the denominator? 1, 2. One more example, 0.222. How many digits after the decimal point? That's 3. How many noughts in your denominator? 1, 2, 3. That's a key point, remember.
Now that we've tackled converting from decimals to fractions, let's look at them the other way round, converting from fractions to decimals. There are 10 balls in a triangle. Let's start off with 3 of those 10, 3/10, and convert this to a decimal.
Well, that's easy. To convert 3/10 into a decimal, we can use division. So here we have 3 divided by 10. 10 into 3 doesn't go. So we put a 0, decimal point, decimal point. Keep them in the same place. So we carry the 3 over. Now we have 10 into 30. That goes 3 times exactly. So 3/10 can be written as a decimal in the form of 0.3.
Take another fraction, 2/5. Let's convert that to a decimal in the same way.
Now we want to convert 2/5 into a decimal. So we divide 2 by 5. 5 into 2 doesn't go, so we put a 0. Keep our decimal points in the same place. Now we carry the 2 over. 5 into 20 goes exactly 4 times. So 2/5 can be written as a decimal of 0.4.
Sometimes the numbers to be divided are not quite as easy. Let's look at recurring decimals.
Now let's take 1/3 and try and convert that into decimals. You'll notice something interesting here. Now we're going to put 3 into 1. Doesn't go, so we put a 0. Keep our decimal points in exactly the same place. Carry the 1 over. 3 into 10 goes 3 times with a remainder of 1. 3 into 10 goes 3 times with a remainder of 1. 3 into 10 again goes 3 with a remainder, and so on and so on. Let's check that with a calculator now. We could write 1/3 as 0.33. But because the 3's keep on coming again and again, they're recurring. So we call this a recurring decimal. To show that, we put a tiny dot above the 3. Now that indicates that it's a recurring decimal. Now let's go on to another example. This time we've got the fraction 2/3. So again, I've written it out like this. We divide the 2 by 3. So here we go. 3 into 2 doesn't go. Okay, so that's 0. Decimal point and the decimal point in the answer. We carry the 2. Okay, so 3 now into 20 goes 6 times with a remainder of 2. 3 into 20 goes 6 times with a remainder of 2. Again, 6 times, and that's recurring. So 3 into 2 is 0.666, recurring, and so on. Now, if we want to round the answer to 2 decimal places, it would be 0.67.
Right, we've checked through some basics, so let's turn to a test question. There are 4 parts to this question, so you'll need to pause in between each part to make a note of the figures. Or you can find all the details on our website. Here are 5 number cards. Jot down 3/20, 0.7, 0.75, 4/5, and 0.15. 3 of them show decimals and 2 show fractions. Part A. Which decimal card is equal to 7/10? Part B. Which fraction is equal to the decimal 0.8? Part C. Which decimal is equal to 3/4? And Part D. Which 2 cards are left over and are the equivalent? Stop the tape and have a go at the question yourself. Okay, lots to work through there. So let's hear what answers the lead chief marker for Key Stage 3 Maths is going to give us. And he's going to take each part one at a time. Part 1. Which decimal card is equivalent to 7/10?
The first number after the decimal point always tells us the number of tenths, so the equivalent of 7/10 must be 0.7.
Okay, on to Part 2. Which fraction is equivalent to the decimal 0.8?
0.8 is equal to 8/10, but there is no 8/10 card. 8/10 can be simplified by dividing the numerator and the denominator by 2, making it 4/5, and that does match one of the cards. If you are in any doubt about an answer, you can check it by looking at it the other way round. 4/5 multiplying top and bottom by 2 gives 8/10, which is equivalent to 0.8.
Okay, just 2 parts to go. Now for Part 3. Which decimal is equivalent to 3/4?
An easy way to convert a fraction into a decimal is to divide the numerator by the denominator. In this case, it means dividing 3 by 4. If you divide 3 by 4, the result is 0, remainder 3. Now divide 30 by 4. That gives 7, and 7 4s are 28, so the remainder is 2. Finally, 4 into 20 is 5, with no remainder. So the result is 0.75.
Now for part 4. Which two cards are left over and are they equivalent?
The two cards left over are 3/20ths and 0.15. Let's see if they are equivalent. Start with 0.15. That is 15/100ths. If you divide the numerator and the denominator by 5, you get 3/20, 3/20ths, which is the same as the other card.
So how'd you get on there? Problems like this can be quite tricky because if you make a mistake in the early part of the question, it can mean that you go wrong at the end as well. So check through carefully. To recap, let's go to some key points. When converting between a fraction and a decimal, write the decimal as a fraction with a denominator of 10, 100 or 1000 and then simplify by cancelling down. When converting a fraction to a decimal, divide the numerator by the denominator and make sure the decimal point remains in the right place. In the final section, we're looking at adding and subtracting fractions. You can only add or subtract fractions that have the same denominator. So you add or subtract the same type of fraction. Quarters and quarters, eighths and eighths, twelfths and twelfths, or whatever. But what happens if the denominators are different?
So if we have fractions with different denominators, the first thing we have to do is convert them into the same type of fraction so that we're using a common denominator. They have the same denominator. Now 4 and 6 both go into 12. Now let's convert those into 12. So 1/4 times by 3 will give you 3, but 4 times 3 will give you 12. So you've converted a quarter into a 12th there. Now let's do the same for the 6th, 1/6. Now whatever you do to the denominator, you must remember to do to the numerator as well. So 1 times 2 is 2. 6 times 2 equals 12. So 1/6 can be written as 2/12. Now that we've got the same denominator, we can add the two fractions together because they are of the same type. So we've got 3/12, add 2/12, and that equals simply 3 add 2 is 5/12. So a quarter add a sixth is 5/12. Now let's move on to subtraction. Again, we have to have a common denominator. So we need to convert the 4 and the 6 into 12ths because both of those numbers go into 12. Let's do that again. 1/4. 4 multiplied by 3 gives you 12. We have to do the same to the numerator as we have done to the denominator. So that's multiplied by 3. 1 times 3 is 3. Again, let's do the same for the 6th. 6 times 2 gives you 12. Again, do the same to the numerator. 1 times 2 gives you 2. Now we can subtract our fractions. This time we've got 3/12 minus 2/12 gives us an answer of 1/12. So a quarter minus a sixth is 1/12.
And for a demonstration on the pool table, here's our expert pool player. A quarter plus a sixth, and there are 12 balls in a set. A quarter would be 3. A sixth would be 2, making 5 altogether. Now for a typical test question where you'll need to use equivalent fractions. It comes in 2 parts, so you'll need to make a note of the figures. Part A. In a magazine there are 3 adverts on the same page. Advert 1 uses a quarter of the page. Advert 2 uses an eighth of the page. And Advert 3 uses 1/16 of the page. In total, what fraction of the page do the 3 adverts use? Show your working. Part B. Cost of advert, £10 for each 1/32 of a page. An advert uses 3/16 of a page. How much does the advert cost? Okay, how did you get on there? Let's take the question from the top. We're told that the adverts use a quarter, an eighth and a 16th of the page and are asked what fraction of the page the 3 adverts use altogether.
You need to add 1/4 and 1/8 and 1/16. As you can only add or subtract fractions with the same denominator, you need to find a denominator that can be common to all of them. Both 4 and 8 divide into 16, so 16 can be the common denominator, and you can change quarters and eighths to 16ths. Now 4 times 4 equals 16, so 1/4 is 4/16. 8 times 2 is 16, so 1/8 equals 2/16. Now you can add them all together. 4 plus 2 plus 1 makes 7, so the advert makes up 7/16 of the page.
Now for part 2. 1/32 of a page costs £10, and we want to find the cost of an advert that uses 3/16 of a page.
You know that 1/32 of a page costs £10. So you need to convert 3/16 into 30 seconds. Then it'll be easy to work out what the advert will cost. 2 times 16 is 32. So 3/16 is 6 30-seconds. Now 1/32 costs £10. 6 30-seconds costs 6 times as much, so the answer is £60.
Right, let's go to the key points to recap. Only fractions with the same denominator can be added or subtracted. For instance, 2/9 can be subtracted from 7/9 to make 5/9 because they both have a denominator of 9. For fractions with different denominators, find equivalent fractions for all of the fractions being added or subtracted so that they all have the same denominator. For example, a quarter and a third can't be added, but 3/12 is equivalent to a quarter and 4/12 is equivalent to a third. Now 4/12 and 3/12 can be added to make 7/12 because they both have the same denominator of 12. That's the end of this unit on fractions. Remember, you can rewind the tape as many times as you like until you're feeling happy about what we've gone through. And there's more information and practice questions in our Key Stage 3 bite-sized book and on our website. In this unit, we're going to look at percentages, what they mean and how to work them out. Now, percentages seem to be everywhere you look. You'll often see signs offering reductions. You may also often hear about percentages in the news.
Today's the day when 1 million public sector workers will find out how much their pay rise is going to be.
To attract more people to training, newly qualified nurses are expected to get 11%.
Meanwhile, teachers are also expected to get a pay rise of between 3% and 4% when the government announces its response to the pay review bodies later today.
But what do they actually mean? while percent means parts out of 100. So 1% means 1 part out of 100, 2% means 2 parts out of 100, 50% means 50 parts out of 100, and so on. But before we go any further, take a look at this.
This range is in pushcorn, isn't it, Mr. Huntley?
Right, first time, Mr. Granger. 35% wool, 35% pushcorn.
Well, that only makes 70%.
Yes, well, there's a lot of air between the fibres, sir.
Most of the numbers we come across in day-to-day life describe actual amounts or quantities. 2 meters of cloth, 3 handkerchiefs, 25 pence in change, and so on. And if I change the amount, I change the number. There, now it's 50 pence. But percentages, proportions and ratios are ways of sharing things out. Percent means parts in 100. 1% means 1 part in 100. 6% means 6 parts out of 100, and so on. So a percentage is a fraction of 100. 100% of anything is the whole lot. So if one sock is 100% pure wool, a pair of the same socks is also 100% pure wool, even though I now have twice the amount of wool. If I imagine something divided into 100 parts, then the number in front of the percent sign tells me how many parts of the 100 I'll get as my share. The best way to start thinking about percentages is as pennies in the pound. So, with 100 pennies in a pound, 10% is 10 parts of the 100, or 10 pence. 50% is 50 pence, and 100% is 100 pence, the whole lot. Now, if a sale sign says there's 10% off the marked prices, then on something marked £1, I would save 10 pence. On something marked £2, I would save 2 lots of 10 pence, that's 20 pence. And on something marked £3, I'd save 30 pence. The actual amount I save varies, 10, 20, 30 pence, but the saving is still 10% of the original price.
Okay, now let's move on to calculating percentages.
A percent is a part out of 100. We can simplify this fraction by dividing both the numerator and the denominator by the largest number which goes into both of them, which in this case is 10. That equals 10 divided by 10 and 100 divided by 10, which gives us 1 over 10. So that's our simplified fraction. If we do that division, 1 divided by 10 gives us a decimal of 0.1. So 10% can be expressed as a decimal as 0.1. We can visualize this as 1 out of 10. We filled in 1 square to represent 1/10 or 10%. Let's look at another example. 25% is 25 parts out of 100, or 25 hundredths. If we simplify this, 25 hundredths becomes 1/4, 1 divided by 4, which gives us an answer of 0.25. So 25% converts to a decimal of 0.25. Before the test, you should try to ensure that you're familiar with common percentages, like 50%. So let's do this example here. 50% is 50 parts out of 100, which simplifies to 1 over 2, or a half, which equals 0.5. We can visualize this, so we can see that 50% expressed as a decimal is 0.5. 75% is another common percentage. 75% is 75 parts out of 100, or 75 hundredths. Again, if we simplify by dividing both the numerator and the denominator by 25, we have 3 divided by 4, or 3/4. We can express that fraction as a decimal by dividing 3 by 4 to give an answer of 0.75. So 75% may be expressed as a decimal 0.75. We can visualize this like that. 20% is 20 parts out of 100, which is 1/5. 1/5 can be expressed as a decimal by dividing 1 by 5, which gives us an answer of 0.2. And we can visualise that as 1 out of 5.
Right, now that we understand the relationship between percentages, fractions and decimals, it becomes easier to find the percentage of any quantity.
When doing calculations involving percentages, 10% can be a useful guide. If an example here, where shoes are being sold for £24 and we're interested in a reduction of 5%, we could start by first calculating what 10% of that value is and then dividing it by 2. Let's remind ourselves of something though. 10% equals 1/10. In mathematics, when we find a percentage of something, it's the same as to multiply. So if we want to find 10% or 1/10 of £24, we multiply by 1/10. £24 times 1/10 equals £2.40. But we're interested in 5%, which is half that value. So we divide £2.40 by 2, which gives us an answer of £1.20. 5% of £24 is £1.20. A reduction of 5% might not encourage very many people to buy the shoes. Just suppose a shopkeeper decided to have a reduction of 15%. What we do here is, again, we can use the 10% as a guide, and we find 10% of £24 and add to that 5% of £24. So let's do that. £10 of £24 equals £2.40. And half of that amount is 5%, so we find out 5% of £24 is half this amount, which is £1.20. So for 15% we add these together, which is the same as adding these together, which gives us £3.60. So 15% of £24 is £3.60.
Right, let's now move on to percentages that can't be calculated from 10%.
Let's consider an awkward percentage like 3% of £24. Let's remind ourselves that percentages are parts of 100. So 3% is 3 parts out of 100. Now we can express this as a decimal. 3 divided by 100 equals 0.03. Now, of in mathematics is the same as multiply. So 3% of £24 is the same as 0.03 multiplied by £24. That equals an answer in pounds of 0.72, which is the same as 72 pence. Taking another example, 98% of £24. Remembering that percentages are parts of 100, 98% then is 98 parts out of 100. Expressed as a decimal, this equals 0.98. Now, as we said before, of in mathematics means multiply. So 0.98, which is 98%, of £24 means multiply by £24. This gives us an answer of Now, we can do a quick check. Does this answer make sense? Well, 98% is very close to 100%, and the value that we have here, £23.52, is very close to £24. So yes, it looks like our answer is correct.
So far, so good. Let's now remind ourselves of how to express one figure as a percentage of another.
Let's take a maths class as an example. We would like to express the number of boys in the class as a percentage. So first of all, let's write it as a fraction. 12 boys out of 30. Now we can simplify this, dividing both the numerator, the top number, and the denominator, the bottom number, by 3 to give us 4 over 10. Now, we expressed it as a fraction. We multiply this by 100 to get our percentage. 4 over 10 times 100. Now this gives us 400 over 10, which simplifies to 40%. Let's take another example. This time we're interested in the number of boys who are rugby players. We want to see this expressed as a percentage, but first of all we start with a fraction. 3 over 12. We can simplify this, dividing both the numerator and the denominator by 3 to give us 1 over 4, or a quarter. Now we multiply this by 100. Which gives us 100 over 4. Dividing that down, we get 25%. Now, does this answer make sense? 25 times 4 is 100, so yes, that seems to be correct.
Okay, let's recap on the key points so far. To express one number as a percentage of a second number, write the first number as a fraction of the second number and then multiply by 100 to make the fraction a percentage. Now, do you remember the boots? Well as percentages being useful to buyers to work out the saving made on items in a sale, percentages are also useful to sellers to work out their profit. Percentage profit is defined as the amount of profit divided by the original price multiplied by 100.
We're back in the shoe shop, and we have a pair of shoes whose original price is £60. Now, of that £60, £9 is profit. We wish to express that profit of £9 as a percentage. Now, we have a formula that can help us to calculate this. Percentage profit equals profit divided by original price times 100. So let's put the numbers in. So we can take the profit of £9 and divide that by the original price of £60. We can simplify this, dividing both the numerator and denominator by 3 to give 3 over 20. Right, to find the percentage, 3 over 20 times 100 gives us 300 divided by 20. This simplifies to 30 over 2, and an answer of 15%.
Okay, now time for a test question. And like a lot of the test questions, it's quite long and it has to be answered in 2 parts. So pause the tape to write down figures and details, or you can go to our website and work through the same question there. The table shows the land area of each of the world's continents in 1,000 square kilometres. Going down the table, we can see that Africa accounts for 30,264, Antarctica for 13,209, Asia 44,250, Europe 9,907, North America 24,398, Oceania 8,534, and South America 17,793. The total land area of the world is 148,355. Part A asks which continent is approximately 12% of the world's land area. And part B, what percentage of the world's land area is Antarctica? And remember to show your workings out. Okay, now that you've had a chance to work through the question, let's take a look at what the lead chief marker has to say. Which continent is approximately 12% of the world's land area?
The question uses the word approximately, so start by looking at a percentage that's close to 12, but will make the calculation easier, say 10%. Now work out what 10% would be. 10% of the area of the whole world is 1/10 of 148,355, and that's 14,835.5. Now 12% is a little more than 10%, so looking down the table, you're looking for a figure that's a little higher than 14 or 15,000, and so it looks like South America. That has a land area of 17,793, which is the only number that could be approximately 12% of the land.
So far, so good. Okay, let's move on to the next part of the question, which asks, what percentage of the land area is Antarctica?
All the units in the table are in 1,000 square kilometres. But as we're going to divide two numbers, we can ignore this and just use the numbers as they are in the table. The area of Antarctica is 13,209,000 square kilometres, and the area of the whole world is 148,355. So if we divide 13209 by 148,355, and to turn it into a percentage multiply by 100, the answer will be 8.9%.
Just to recap, let's go over the key points you need to remember about percentages. Percent means parts out of 100. A percentage can be changed to a fraction by writing it with a denominator of 100. A percentage can be changed to a decimal by dividing by 100. And that's the end of this unit on percentages. If you want, you can rewind the tape and play it back as many times as you like until you feel confident. And as always, there's more information and other exercises to help you in our Bitesize book and on the website. Oh, and don't forget to take a breather. Right, now let's move on to negative numbers. Very often we see negative or minus signs, especially when it comes to bank statements and money owed. But how can you actually have a negative number? Well, this diver may be able to offer a few clues.
Good cutaway, just a touch short, and scoring for his lowest dive in terms of tariff.
Impressive stuff, eh? Well, that's one way to think about negative numbers. In this first dive, he's going to climb up the board, which is 10 metres above the water, and then dive down until he gets to approximately 4 metres below the water. The distance the diver climbs up to the board and the depth he reaches when he dives down into the water can both be represented on a number line. We can make the surface of the water 0, the numbers showing the height above the water positive, and the numbers below the water negative. As you look down a number line, the numbers get smaller, and this continues past 0 into the negative numbers. So starting at 10 metres, the positive numbers get smaller as he dives down the number line. Once the diver goes underwater, the numbers continue to get smaller as he descends further down the number line, finally swimming to minus or negative 4 metres. This time the diver starts at a higher point, approximately 15 metres above the water, so when he dives, he goes deeper into the water to minus 8 metres, a smaller number. So the rule to remember is that as you go further up the number line, the numbers, whether positive or negative, get larger. So -2 is larger than -5 because -2 is further up the number line. In the same way, +2 is smaller than +5 because +5 is further up the number line. But the number line can be both vertical and horizontal. If we think of the number line horizontally, then the further right we go, the numbers, whether positive or negative, get larger. Now, addition with negative numbers is also made easier by using a number line. Here's a few examples.
What we have here is a number line stretching from +5 to -5. And we can use this in order to find the value for a simple calculation. -2 or -2 plus 4. What does this equal? The first thing that we do is we locate -2 on the number line. So let's highlight that. -2 is here. And then what we do is we move up the number line because we're adding a positive value. 1, 2, 3, 4, which brings us here. So the answer here is -2 or -2 plus 4 equals 2. Okay, let's try another example. Here we can see 3 plus -7. What does that equal? Well, the first thing that we do is we locate 3 on the number line. That's here. And now we add -7, which is the same as subtracting 7. So we move down the number line. 1, 2, 3, 4, 5, 6, 7, which brings us here to -4. So the answer then is -4 or -4. Okay, let's try one more example. -1 plus 5 plus -7. Once again, the first thing we do is locate the number on the number line. -1 is here. We go up 5 plus 5. 1, 2, 3, 4, 5 brings us here to +4. And then we go down. 1, 2, 3, 4, 5, 6, 7 brings us to -3, and that is our answer. -3 or -3.
Right, we're on a roll now. Let's try another question here. There are 5 parts of this one, so just as you did before, you'll need to pause the tape and jot down the figures. Or if you'd rather, you can work through the question on our website. Here is a list of numbers. -7, -5, -3, -1, 0, 2, 4, 6. You can choose some of the numbers from the list and add them to find their total. For example, 6 plus -1 equals 5. Part A. Choose 2 of the numbers from the list which have a total of 3. Part B. Choose 2 of the numbers from the list which have a total of -1. Choose 2 other numbers from the list which have a total of -1. Part C. What is the total of all 8 of the numbers on the list? And Part D. Choose the 3 numbers from the list which have the lowest possible total. Write the 3 numbers and their total. And you mustn't use the same number more than once. Stop the tape while you work it out for yourself. So how'd you get on there? Well, come on, let's go through the answers together. Part A. Choose 2 of the numbers from the list which have a total of 3.
Begin by putting each number in turn at the beginning of the number sentence, and then seeing if you can find another number that will make the correct total. If you put -7 in here, you would have to add 10. And there is no 10 in the list, so you cannot use -7. For -5, you would have to add 8 to get to 3. So that's no good, as 8 is not in the list either. For -3, you would add 6. So that's fine, as 6 is in the list, and you could write -3, add 6, or of course 6, add -3.
But you'd also get full marks if you found another pair of numbers that add up to 3, because this is one of those questions where there's more than one correct answer.
For example, if you put -1 here, you could add 4 to make 3. Or again, you could swap them round and put 4 add -1 and still come to the total of 3.
Right, on to part B. Choose two numbers which add up to -1.
Beginning with -7 and then adding 6, that would make -1. Or the other way round, 6 add -7.
Right, now for the next part. Choose two other numbers from the list that have a total of -1.
There are 6 possible answers. You could have -5 add 4, or 4 add -5, or -3 add 2, or 2 add -3, or lastly 0 add -1, or -1 add 0.
What about part C?
For this part, you are asked the total of all 8 of the numbers on the list. Using the number line, start at -7. Add -5, which is like subtracting, so move down 5 to -12. Now add -3 to that, so move down 3, which takes it down to -15. Then add -1 to that, giving -16. Now add 0, which leaves the number alone at -16, and then add 2, which moves up to -14. Then add 4, which moves up to -10, and finally add 6, ending up at -4. So the answer is -4.
And finally for part D. Choose the 3 numbers from the list which have the lowest possible total. Write the 3 numbers down and their total. You mustn't use the same number more than once.
The 3 smallest numbers will give the lowest total, so that will be -7, add -5, add -3, which totals to -15.
When adding positive numbers, imagine moving up the number line. And when adding negative numbers, it's like subtracting, so imagine moving down the number line. Right, that's the end of this unit. You can go over it again if you want, or move on to the next one. And for even more information and test practice, don't forget you can look up negative numbers in the book and on our website. Okay, we're now moving on to the unitary method. And like unit, it means one single thing. So we find out about one thing as a step to calculating or finding out about more than one. Now don't worry, it's not quite as complicated as it sounds. Here's an example. A special offer, 3 CDs going for £21. But I'm planning to buy several packs and sell the CDs to my friends. I don't want to make a profit, so how much should I charge for 8 CDs?
So using the information available to us, 3 CDs cost £21. Now 3 divided by 3 gives us 1, and in the unitary method we need to find the cost of 1. So 1 CD costs 21 divided by 3, which equals £7. Now we're interested in 8 CDs, so 8 times £7, which equals £56. And there's your answer.
Unitary, like unit, means one single thing. So the unitary method means finding out about one thing and using that information to find out about several things. So that's the basis of the unitary method. Now let's talk about holidays and money. If we're going abroad and we need to change money, then we have to use conversion rates to see how much of another currency we get in exchange for our own. And the unitary method is a good way of doing those calculations.
Here at the airport, it's all happening, and just here has got to be one of the most important locations on the airport site. It's the Bureau de Change. This is the money exchange where you change your British money, your sterling, into the currency of the country, whichever one it is you're visiting. In my case, could I have £100 in pesetas, please?
Certainly.
Right, so you've got, let's see, pesetas if you're going to Spain, you've got francs if you're going to France, Germany, you've got Deutschmarks, Japan, you've got yen, and America, you've got dollars.
20,000 pesetas.
Tremendous. Thank you very much
1,
indeed. You know,
2,
I
3,
love
4,
this bit.
5, 6,
this is just
7,
great. You get
8,
your hands
9,
on a
10,
great
11, 12,
wad
13, 14, 15,
of
16,
interesting looking
18,
notes.
19, 20,000.
Thank you very much indeed, sir.
Okay.
Look at that. The thing is, I don't really know exactly how much all this is worth, but Andy Williams knows. He works with foreign money every day. Andy, what's people's reaction usually when they get a great wad of money like this?
Normally they think they're rich because they're still thinking in English when they're changing their money. So for 20,000 pesetas, they think it's £20,000, and they obviously think they're rich.
So, what currencies do you exchange most of?
Pesetas, dollars, Italian lira, and Greek drachma.
All right, so people are going to Spain, they're going to, what do you say, pesetas, lira, Italy, drachmas, Greece, right, and American dollars. All right, let's go and find out if people know what the peseta in their pocket's actually worth. Where are you flying to today?
Canary Islands.
Okay, what's the currency in the Canary Islands?
Pesetas.
Pesetas, all right. Is it a nice T-shirt? Good T-shirt, you'd buy that perhaps?
Yeah, maybe.
Yeah? Okay, 15 quid that T-shirt would cost in this country. I'd sell it to you for 4,000 pesetas. Now, is that a good deal or isn't it?
Yeah, it's a good deal.
I'm afraid it's not a good deal because it's about 200 pesetas to the pound. So really, you're paying 20 quid for something that's 15 quid. 3,300 is nearer the mark. Okay?
Yeah.
Excuse me, can I ask you a couple of questions?
Sure.
Where are you travelling to today?
Portugal.
Portugal, okay. Have you exchanged your money yet?
Yes.
Good, all right. Well, you should know what we're talking about. Okay, this T-shirt, I would sell to you for about £15 in this country. Right. Now, if I were to offer it to you for 2,000 escudos, is that a good deal?
Yes.
Yes. It is. Okay, how much is that? Do you realise?
About
It's about...
£6 or £8.
It is, it's £8. How did you work it out?
Because I think it's 250 escudos per pound. I think.
That's absolutely right. Excuse me, can I ask you where you're flying to today?
Verona.
In Italy?
In Italy.
All right, so that's lira. Well,
yes.
Consider this T-shirt for a moment, right? Now, that would be about £15 in this country. If I offered to sell that to you for 36,000 lira, is that a good deal or a bad deal?
36. That's slightly dearer than in England.
Ever so slightly dearer.
Yes, slightly.
It's pretty close, actually.
Yeah, so it's slightly dearer.
So it's about the same price.
Yes.
So would you buy it anyway?
No, not for that price.
So let's go through currency conversion. If I wanted to change between pounds and dollars, I could use the unitary method.
What we want to do here is to find out how many dollars I would get for £100. So let's have some information help us with this. This is an example of an exchange rate. £1 equals $1.64. But we're interested in £100. So, £100 times £1 gives us £100. Whatever we do on the left-hand side of this equation, we also need to do on the right-hand side. So, 100 times $1.64 gives us an answer of $164. Just suppose we were interested in finding out how many dollars for £125. The same principles apply. 125 times our exchange rate of $1.64 gives us an answer of $205. If on holiday in the United States I decide I want to buy something for $170, how much money in English pounds would I need to spend? Okay, we already know the exchange rate. $1.64 equals £1, but we wish to know the value for $1. If we know that value, then we multiply it in a simple calculation to find out how many pounds we need for $170. Okay, so the first thing we need to do then is to convert this to $1. We divide 1.64 by itself to get that answer of $1. So the amount in pounds that we're looking for is 1 divided by 1.64, which equals, in pounds, 0.6097. And we can round this up to be 0.61. So what we have to do now is multiply this value by 170. So, 170 times 0.61 equals 103 pounds and 70 pence.
Okay, now let's go to some questions, the kind you might find in your test. And there are two parts to this question, so it might be a good idea to jot down the details as you're going along, or you can always access the same question on our website. Part A. Use £1 equals 9.6 knot francs to work out how much 45 pence is in francs. Show your working. Part B says to use 240 pesetas equals £1 to work out how much 408 pesetas is in pounds. Both parts of the question remind you to show your workings, but remember, for all questions, whether you use a calculator or not, it's important to show how you worked out your answer. So how'd you get on there? Well, come on, let's look at the first part. Use £1 equals 9.60 francs to work out how much 45p is in francs. And remember to show your workings.
£1 equals 9.60 francs, and you want to find 45 pence. That's 0.45 pounds. So multiply 0.45 by 9.60, giving 4.32 francs. That looks sensible, because 0.45 pounds is roughly half of £1, and you would expect the amount in francs to be roughly a half of 9.60 francs.
So, on to the second part. Use 240 pesetas equals £1 to work out how much 408 pesetas is in pounds. Show your workings.
240 pesetas equals £1. So 1 peseta equals 1 divided by 240. Now to find 408 pesetas, we must multiply by 408. So 1 divided by 240 multiplied by 408 gives 1.7 pounds, or £1.70.
Find the value of 1 unit if this is not given. Multiply to calculate a larger number of units. Well, that's it for this unit. There are more examples and questions in the book and on our website. Remember, you can rewind and recap on any of those calculations, or it might even be a good idea now to take a short break before you move on. Okay, it's now time to move on to our unit on time. Now, time is measured in seconds, minutes, hours, days, weeks, months, years, decades, centuries, even millennia. But first, let's remind ourselves of the basics. 60 seconds equals a minute. 60 minutes equals 1 hour. 24 hours equals 1 day. 7 days is 1 week. 28, 29, 30 or 31 days is 1 month. 12 months is 1 year. 365 days equals 1 year, or 366 days equals 1 leap year, and 52 weeks is 1 year. Now, to change minutes into seconds, multiply by 60. So for instance, to change 9 minutes into seconds, I'd multiply 9 by 60, which is 540 seconds. It's the same thing to change from hours to minutes. You multiply by 60. So 2 hours would be 2 multiplied by 60. That's 120 minutes. And to change seconds into minutes, going the other way, we divide by 60. So 180 seconds is 180 divided by 60. That's 3 minutes. Now, if I look at my watch, I can see straight away that it's divided into 12 hours. And we know the day is divided into the 12 hours before noon, that's AM. And the 12 hours afternoon is PM. Now, this morning, I got up at 7:15 AM, very early. And tonight, I'll probably go to my bed around 11:30 PM. But time can also be measured in the 24-hour clock. That means that there's no AM or PM, and all times are read with 4 digits. For times before 10 AM, a 0 is placed at the beginning. So I would say I got up at 07:15 hours. And after 12 noon towards 1 PM, it doesn't read 1, but instead 1300 hours. So that means I'm going to my bed tonight at around 2300 hours. So the thing to remember here is that for any times past 12:59 hours, 12 is added to the 12-hour clock time to find the 24-hour clock time. So 1 PM becomes 1 plus 12. That's 1300 hours. 2 PM becomes 2 plus 12. That's 1400 hours, and so on. Right, let's move on to timetables. These tourists want to get from London to Rugby and back, leaving London in the morning and coming back by 6 PM the same day. They'd like to spend as much time as possible in Rugby. This row shows what time the trains leave London. And this row shows what times the trains leave Rugby to come back to London. It seems that to get to Rugby and back by 6 PM or 1800 hours, they'd have to catch the 0840 from London in the morning and take the 1652 or 452 from Rugby to London in the afternoon. Okay, now let's move on to a test question. And there are 2 parts to this one, so you might like to jot it all down as we go. Amy and Miranda meet in town after school. They each use different clocks to check their times of arrival. Part A. Amy arrives first and looks at her watch. What time does Amy's watch say? Then Miranda arrives using the 24-hour clock on a parking ticket machine. What time does the parking ticket machine say? Part B. How long has Amy been waiting by the time Miranda arrives? Okay, so how do you get on there? Well, let's go through the answers, taking each part at a time. What time does Amy's watch say? What time does the parking ticket machine say?
Let's look carefully at each of the clocks. This first clock says 3 minutes to 5. The second clock says 17:13, 5:13 p.m. To make it easier, let's put both times in the 24-hour clock. 3 minutes to 5 is the same as 4:57 p.m. and in the 24-hour clock this is 16:57. The other figure is already in the 24-hour clock. That's 17:13. Now let's look at the time each girl arrives. Amy arrives first and looks at her watch. Amy's watch says 4:57 p.m. or 16:57 in the 24-hour clock. Then Miranda arrives, using the 24-hour clock on a nearby parking machine to tell the time. It says 17:13.
Right, now for part B. How long has Amy been waiting by the time Miranda arrives?
Well, Amy arrived at 16:57 and Miranda at 17:13. So 16:57 add 3 minutes takes us to 1700, and then another 13 minutes takes us to 17:13. That's 16 minutes that Amy has been waiting.
To change minutes into seconds, multiply by 60. To change from hours to minutes, multiply by 60. To change seconds into minutes, divide by 60. And to change minutes to hours, divide by 60. Time can be read in either the 12-hour clock or the 24-hour clock. In the 24-hour clock, time is always written using 4 digits. To convert times from the 12-hour clock to the 24-hour clock, add 12 hours to all times after 12 noon. Well, that's it. Time's up on this unit on time and this first maths programme. Don't forget, there's always more information and more practice questions in our book and on our website. Oh, and before you go on to the next programme, don't forget to take time out.
Details of all BBC Learning Zone programmes can be found on CFAX pages 630 to 635.